Hi everyone, and welcome back to this series of solving electronics questions for the PEO exam. And this exam is Electrical A5. Today, we'll see how to handle a DC bias question for the bipolar junction transistor, or for short, BJT. This question comes in May 2015, December 2018 exam. So basically, it is asking for the voltages VC or VE with different configurations, NBN transistor, BNB transistor, but the beta, the saturation voltages, the forward, the BE voltages are all the same for all questions. Now, because there are certain ideas, I will just do part A, B, and C, which covers all different ideas. You can do part D and E by yourself. But before we go there and solve the question, let's go for a bit of background, how to handle such a question. This is called DC bias BJT question. So BJT, there are two types of them, the NBN and BNB, as you see here. The main difference in the direction of the current and the polarity. Everything is basically reversed. And this is for the NBN, and this is for the BNB. The transistors comes with different mode of operation. In the questions, mainly they are in the active region. Sometimes it's stated that the transistor is an active region, but in DC bias question, they will not say anything. So you have to assume a mode of operation for the transistor, and then you have to verify it. How to verify it? These are the voltage relationships. So you assume, usually we start with the active mode because this is the most common mode, and we solve the questions as we will see. And then after that, we do the check. So for example, if it's an NBN transistor, we assume that it's an active mode. If VC is more than VB more than VE, then it is our assumption was correct. If not, then we'll see, we assume the saturation. So it's basically between active and saturation. So let's see how to handle this. Is NBN transistor. As I said, the BNB transistor, everything the same, but reversed, the polarity and the current direction. So assume that we start with an active mode. So these are the equations that we will do. The first one is the simple equation, the KCL equation. That is IE, the current leaves the emitter, is equal to IC plus IB, or IB equal to IE minus IC. Now, IB is a very, very small current. So IC and IE are very close to each other. There is a relationship that IC is equal to alpha times IE. Usually we are not given alpha, we are given beta, which will derive it soon. Now, since IB is IE minus IC, I will come here and substitute the value here, and we'll get IE 1 minus alpha IE, or take 1 minus alpha as a common factor. Okay, and then we will actually just divide this equation with this equation. So IC over IB will equal to this, IE will cancel. So we'll have alpha over 1 minus alpha, and we will get beta. Beta is a very important constant that is usually given in the question, and we will use it in the active mode. So basically your IC is equal to beta IB. So all I need to find is IB. Once I know IB, I can find IC with this relationship. Once I know IC, applying KCL, I can get IE. So the whole problem here becomes how to find your IB. Now, you go and you do the check, and you found that no, it's not. This is not active, it's a saturation. In the saturation mode, the only equation that is applicable is the KCL, and VCE, the voltage between VCE, is equal to a constant value, which is 0.3, 0.4, 0.2, depends what the question is giving you the value. But you cannot use any of those formulas of the beta or the alpha. So that is how you approach the problem in a very short period of time. So now let's go to the question, and we will start with question A. So what we want to find here, we want to find basically the VC. What is your VC? Okay. Now I will have here, this is an NBN transistor. So this is your IC, this is your IB, this is B, this is E. So this is VBE, which is equal to 0.6 volt. Okay, so let's do KVL. So this is basically a voltage supply here, 2 volt. And this is a voltage supply, 5 volt. Okay, so we'll do KVL in this loop. So KVL. So what do we have here? We will have, so the current IB is going into, so we have 20 KIB plus VBE, which is the 0.6 volt. Continue with the KVL minus 2 equal to 0. So we will have here your IB is equal to 1.4 volt divided by 20 kilo, which is equal to 0.07 milliamp. Now, here, as I said before, we always assume it's an active mode. We assume it is active, assume active mode. So we have to assume this. We have to assume certain mode of operation. Now, since that this is your assumption, your IC would equal to beta IB. Beta is given as 50 times IB, which is 0.07, and this will give me 3.5 milliamp. Okay, now we found IC here, so we will apply KVL in this loop. This is the loop I will be going here. So we'll have, so KVL, I would say loop number 2. So we will have minus 5 plus 1K IC plus VC, which is your unknown, equal to 0. Okay, so your VC will be equal to 5 minus 1K times 3.5 times 10 to minus 3. You have to make sure that the currents are in amps. Okay, so this will cancel, and this will give me 1.5 volt. What is my VB? My VB is the voltage between this point to the ground. So my VB is equal to 0.6. So as a matter of fact, my VC is greater than my VB. And my VE is equal to 0. It's the voltage between here to the ground, so it's equal to 0. So my VC greater than VB and greater than VE. Let's see which mode is this. When you look here, this is an NBN transistor. So this is an NBN transistor. VC more than VB more than VE. It's an active mode. And this is what we assume. So the question is done. Okay. So that's how we approach the VC bias question. Let's go to question number B. Exactly the same thing. The difference here that we have a B and B. So the current direction will change. So that current here, this is your IE, this is your IB, and this is your IC. Okay. Assume active region. So we'll assume the region is active. Exactly the same thing. We'll do exactly the same thing. So we will do KVL in this loop. So I will call this is loop number 1. So this is, as we know, it's the voltage supply. So this is the ground. So we'll start from here, going all the way until we come back here. So we have minus 5 plus 100 times IE plus 0.6 plus the IB, which is 10K IB plus 2 equal to 0. So we will have 100. Now IE is nothing but 1 plus beta IB. So this is equal to 1 plus 50 IB plus 10K IB is equal to 2.4 volt. From this, I can find my IB, which is equal to 0.15089 milliamps. Then IC is equal to beta IB, which is equal to 7.95 milliamps. And IE is either you said it's equal to IC minus IB or 1 plus beta IB as I replace it here. And this will give me 8.1039 milliamp. So let's basically do our check now. Okay, so where is my VB? This is your VB here. Okay, so the VB is the voltage from here to the ground. So your VB is equal to 2 plus the IB current, which is 0.1589 times 10 to minus 3 times 10 times 10 to power 3. And this will give me 3.6 volt. Your VC, on the other hand, your VC is the voltage between this to the ground, which is basically IC times 1 kilo. So it's equal to IC, we just found it 7.95 times 10 to minus 3 times 10 to power 3, which is equal to 7.95 volt. So here your VC is more than VB. Okay, let's check here. Okay, so this is a PNP transistor, and your VC is more than VB in BN, so this is saturation. So it means that your assumption was right. So now we have to redo the question, assume saturation mode. Okay, let me just redraw the circuit now so that can work on it. So this is my transistor here. Now here the formulas of beta, it's not applicable anymore. This is plus 2 volt, and this is plus 5 volt. This is 100 ohm, this is 1 kilo, and this is 10 kilo ohm. Again, this is my IE. This doesn't change. Your IE, IB, IC, these things, they don't change. So you will have here IE KCL equal to IB plus IC. This is my first equation. Now we have one equation, 3 unknowns, so we need 3 more equations. So we will apply KVL to this loop. We will apply KVL to this loop. Okay, so we will have basically minus 5, so KVL. So we will have minus 5 plus 100 IE, which is the voltage drop here, plus 0.6 plus 10K IB plus 2 equal to 0. So now we'll have 100 IE plus 10K IB will equal to 2.4, which is our second equation. I will need a third equation. Now here, you need to use the saturation. So in the saturation, what does it say here in your saturation? That your VCE or VAC is equal to 0.3. Since now this is basically a PNP transistor, so you will have your VEC, this is equal to 0.3 volt. This is constant, okay? So now we'll apply KVL for the outer loop. So KVL, so we will have minus 5 plus, again, 100 IE plus the voltage 0.3 plus 1000 IC equal to 0. So we'll have 100 IE plus 1000 IC equal to 4.7 volt, and this is my third equation. Now we have three equations with three unknowns. We can solve for them. There is no need to go and solve this because now this becomes math. So if you do that, you will find your IC equal to 4.255 milliamp. Your IE is equal to 4.45 milliamp. Now, what do we want to find? We want to find your VE. So your VE is basically equal to if you apply VE voltage from here to the ground, so VE will equal to 5 volt minus the IE, which is 4.555 times 10 to minus 3 times 100, and this will give me 4.55 volt. Now, okay, now we did the calculation. Now we need to do the check. Okay, so let me do the check here. We need to check VB. VB is the voltage between the P to the ground is equal to 2 plus IB, which is the difference between IE. So this is basically IE minus IC. This is your IB times the resistance, which is 10 kilo. You do that, substitute IE and IC times 10 kilo, you find VB equal to 3.95 volt. Find VC, which is the voltage from here to the ground, very simple, is equal to 1K times IC, which is equal to 4.255 volt. So you'll find that your VC is greater than your VB. Your VC is greater than your VB, and your VE is also greater than your VB. So that means that it is in saturation, and your assumption was correct. The last question, which is an interesting question, very tricky question, is this one. We want to find your VE. What is your VE? Here in the B, there is no resistance. There is current, but there is no resistance. The VE is the voltage between here to the ground, which is the voltage between here to the ground. So VE right away is equal to 0.6 volt. It doesn't matter if it's in saturation mode or if it's in active mode. It is always equal to 0.6 volt. So these are some examples how you do the calculations for the DC bias transistors. We will move on and we will solve more questions about BJT transistors. We'll talk about more bias questions, and when we have the transistor acting as an amplifier or AC analysis, how we can handle this.